Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have started with a new chapter, chapter number 3 from chemistry, that is chemical reactions and equations. In this chapter, we have studied what is meant by a chemical reaction and when we call a chemical equation as a balanced one. What are reactants, what are products, and also we have studied the different steps which have to be followed while writing any chemical equation. As usual, in the first 5 minutes, we will just revise the steps which are required for writing a chemical equation, because if you see this entire chapter, it is full of different reactions. And then we will start with a new topic for today, stepwise balancing of a chemical reaction and the different types of chemical reactions. So let us just revise the steps which are required for writing a chemical equation. You all know what is a chemical equation. Representation of a chemical reaction in a condensed form using chemical formulae is known as chemical equation. The first step here is that whenever you write a chemical equation, your reactants, the ones which are going to take part in a chemical reaction, they should be written on the left hand side, whereas the products should be written on the right hand side. Whenever you are writing a chemical equation and there are two or more reactants or two or more products which are formed, then a plus sign should be shown in between that reactants or the products. An arrow heading towards the products. You can see the tail of the arrow is towards the reactants and the arrow is pointing towards the products. The next step is that if you want to make the chemical equation more informative, as I have told you, if any recipe is shown to you on the YouTube, then different ingredients which are required for that recipe are told to you, and that time they give you the proper quantity, the amount which has to be taken, and also the states are told to you that you have to take the sugar in the powder form or different ingredients. So here also, if you want to make your equation more informative, means looking at the equation, a person should come to know that yes, this and this chemical is taken in the liquid form. Here the product carbon dioxide is in the gaseous form. So looking at the equation, if you want to provide information, then the physical states of reactants and products should be mentioned. Now while mentioning the entire name, gaseous, solid, writing will become very tedious. So they are denoted by a small g in the brackets for gaseous state, small s for solid state, small l for liquid state, and aq for aqueous state. Aqueous means whenever any substance is dissolved in water, you call that state as aqueous. Next, certain reactions to be carried out, heat is required or heat has to be provided from outside. So this provision of heat can be shown by a triangle on the top of the arrow. A triangle on the top of the arrow indicates that heat is required to carry out this particular reaction. Next is, all the reactions will not take place under normal conditions. Certain reactions will require the provision of specific conditions like a particular temperature, pressure, or the presence of a catalyst to speed up the reaction. So all these certain conditions, all these specific conditions should be mentioned or indicated on the top or below the arrow. Next, special information or names of the reactants or products are written below their formulae. If you want to write the name of this reactant, copper, then this copper should be written below the Cu, that is the molecular. You can say here it is the symbol of the element. Here it is the molecular formula of nitric acid, which is in the concentrated form. So this is the special information. So that concentrated nitric acid you will write below the molecular formulae. So these are the different steps which we are going to follow. Then we had seen what is a balanced equation. If the number of atoms of the elements in the reactants is same as the number of atoms of those elements in the products, then such an equation is called as a balanced equation. Now, how to balance any chemical reaction? By taking one example which is given in the textbook, we are going to see stepwise balancing of a chemical reaction. Now, a chemical equation is balanced step by step, and here the first step to be followed, the equation or the chemical reaction taken here is sodium hydroxide reacting with sulfuric acid forming sodium sulfate and water. Here you can see the equation or the reaction is written in the word form. So your first step is write the chemical equation from the given word equation. Means you have to convert it into a chemical equation by writing the molecular formulae of the reactants and the products. So sodium hydroxide NaOH plus sulfuric acid H2SO4 gives sodium sulfate, that is NaSO4 plus water. Here we have followed the first step, that is we have written the chemical reaction or equation in the word, from the word equation we have written in the chemical equation form. Now step number 2, we know that we are going to balance the reaction or the equation. Means what we are going to do? We are going to make the number of atoms of the elements in the reactants and the products same. So before that we have to check out whether the equation is balanced or not. So step number 2 is check whether the equation is balanced or not by comparing the number of atoms of the various elements present on both the sides of the equation. So again here you have to create a table. The first column of the table is the name of the element. The second column is the reactants which are on the left hand side, and the third column is products on the right hand side. Write the symbols of all the elements which are involved in the chemical equation. Sodium is involved, so Na, oxygen is there, so O, hydrogen H, and sulfur is there, so capital S. Now count the number of atoms of this elements present in the reactants and in the products and write in that particular space which is provided. So Na is 1 here in the reactants, here Na is 2. So 1 in the reactants, 2 in the products. O is 1 plus 4, 5. And here it is 4 plus 1, 5. H is 1 plus 2, 3. And here H is only 2. Then S is 1. S is 1. Now looking at the number of atoms of the reactants and products, you come to know that they are not equal. So our step number 3 is start the balancing. So first we will start with the balancing of sodium atoms. So number of sodium atoms, initially how many are there? In the reactants how many are there? In the products how many are there? So sodium, you know, in the reactants it is 1 and in the products they are 2. Means NaOH in NaOH reactant, Na is 1, in Na2SO4 it is 2. So that you are going to write immediately. In the reactants in NaOH it is 1, in the products in Na2SO4 they are 2. To balance you have to convert this 1 into 2. So 1 multiplied by 2. Now in NaOH you have multiplied by 2. So immediately in your chemical equation you are going to put a 2 before NaOH. So now your equation becomes 2NaOH plus H2SO4 gives Na2SO4 plus H2O. Now after this equation is formed, you have to check whether this equation is balanced or not. So to find that, again you have to prepare the table. So again we have prepared the table. Elements, reactants on the left hand side, products on the right hand side. Elements symbols remain the same. Now sodium is 2 over here. Here it is 2, so sodium is balanced. But oxygen, you can see 2 plus 4, 6. Here it is 5. So oxygen is not balanced. Hydrogen, 1 plus 2, 3. 2 plus 2, 4. And here it is only 2. And sulfur is 1 on both the sides. So again oxygen and hydrogen needs to be balanced. So hydrogen requires less amount of balancing. So we will start with hydrogen. So number of atoms of hydrogen initially and to balance. So in the reactants in NaOH and H2SO4 hydrogen are 4. In the products in water hydrogen is 2. So if you want to make this 2, then you have to multiply by 2 and then you have to write the final equation. 2 NaOH plus H2SO4. Now 2 you are multiplying here in the water in the product side. So add a 2 over here. Now let us check out whether the equation is balanced or not. Na is 2, Na is 2, O is 2 plus 4, 6, 4 plus 2, 6, H is 2 plus 2, 4, 2 2s are 4. So the equation is balanced. So here we have studied how an equation is balanced stepwise. So the writing of the steps is essential in the exam. I don't think they are going to ask you stepwise balancing of the equation in the exam directly. But as it is a part of the syllabus, we have to cover it. With this, we have seen the stepwise balancing of a chemical equation. Now, in the textual exercise, we will come up with different examples later on. We move towards our next topic, the types of chemical reactions. Here, 4 types of chemical reactions you are going to study: combination, displacement, decomposition, and double decomposition reaction. So let us start with the first one, combination reaction. Look at the word combination. Combination means something is combining and forming something. So let us take up our first activity or the first example which is given in the textbook. Hold a magnesium strip in a pair of tongs and ignite. Ignite means burn. On burning in air, a white powder of magnesium oxide is formed. This experiment you have studied right from the lower standards. Magnesium ribbon, when burnt in air, it combines with oxygen from the air and forms magnesium oxide. So what you can see over here, magnesium combining with oxygen means here one reactant is combining with the other to form a single product, that is magnesium oxide, and such a reaction you call as combination reaction. So as this is a chapter full of chemical equations, we will immediately write the equation Mg plus O2 giving MgO. To balance, you have put the different numbers. So O is 2 over here. So here if you put 2, then Mg also you have to put 2. Now writing the physical states of the reactants, products, everything is essential in the exam. Second example, if you see, NH3 is ammonia when it combines with HCl. So here if you take a small amount of hydrochloric acid in a test tube, that is HCl, and heat the test tube. Then you dip a glass rod in the ammonia solution, that is NH3, and hold it on the top of the test tube. What you will see? You will see a white smoke from the tip of the glass rod. So what is that? Due to heating, what happens? The HCl vapors coming out from the test tube and the ammonia gas, that is NH3 gas, they come out from the solution on the glass rod, and here ammonia gas and hydrogen chloride gets reacted to form a salt which is known as ammonium chloride having formula NH4Cl. So what you can see here, ammonia combining with hydrochloric acid to form one product, that is NH4Cl, combination reaction. Let us take one more example. You have to take a water in a beaker up to half of the capacity of the beaker. Add a few pieces of slaked lime or calcium oxide in the beaker. What will you see? This calcium oxide will combine with water and it will form calcium hydroxide with the liberation of heat, that is different. So here also you can see slaked lime or calcium oxide is combining with water forming a single product, calcium hydroxide, and from this examples we can infer that when two or more reactants combine in a reaction to form a single product, it is called a combination reaction. To prepare chuda in the house, you take rice flakes, that is poha, you take salt, you take turmeric powder, you take some amount of sugar, you take groundnuts, you take some curry leaves, and then the ingredients are fried differently and all are made to combine together, and whatever you get in the dish in the form of crispy chuda is the product. So here many reactants are combining together and forming one product chuda, that is combination reaction. Just for, you can say, entertainment, we have taken an example of our day-to-day life. Nowhere it is linked over here. It is just for you to understand. So two or more reactants combining with each other is called as combination reaction. Now, what are the likely types of questions which can be asked here in the board exam? One is a direct question. Define combination reaction, giving any one example. There you will define and you will give any one example along with the explanation. If you are giving the first example, then you will write magnesium ribbon. In short, magnesium ribbon combines with oxygen from the air on burning, forming magnesium oxide. Then you write the balanced equation. If somewhere your balancing goes wrong, then you will not get a single mark for the equation. This is one way. Secondly, they can give you any half of the equation. You have to complete the space, empty space. Suppose they give block plus HCl gives NH4Cl. So here you have to fill NH3, or NH3 plus HCl forming dash. So you have to complete the reaction. This is the second type. And then you have to identify what type of reaction it is. Or the third type is reaction will be fully provided to you. You have to identify which type of reaction. Now this identification you will come to know when we complete all the four types of reactions. So these are the different types of questions which can be asked on this part. Now we move to the next type of reaction, decomposition reaction. Decomposition. The word itself tells you that something is being broken down, and that is only the meaning of this reaction. Let us see in the example. The first experiment here which is taken as the example is two test tubes have to be taken, a bent tube, a rubber cork for both the test tubes, and a burner for heating. The chemicals which are required to understand this reaction is calcium carbonate, that is CaCO3, and freshly prepared lime water. Now you have to take some calcium carbonate in a test tube. In the first test tube you take CaCO3, fit a bent tube to this test tube with the help of a rubber cork. Insert the other end of the bent tube in the freshly prepared lime water. In this test tube, lime water which is freshly prepared is taken. Calcium carbonate is taken in the first test tube. With the help of the bent tube, the other part of the tube is inserted in the next test tube or the second test tube. Heat or provide heat to the first test tube, that is heat the powdered calcium carbonate in the first test tube very strongly. You will see over here lime water turning milky. How? Here calcium carbonate or CaCO3 on strong heating undergoes decomposition reaction, and when it decomposes forming calcium oxide, that is CaO, with the liberation of carbon dioxide gas, and this carbon dioxide gas which is formed, it turns lime water milky. You all know carbon dioxide turns lime water milky. We have even studied in the 9th standard under section A chapter when we had studied the properties of carbon dioxide gas. calcium oxide powder, that is CaO, it remains behind in the first test tube. So calcium carbonate was a reactant. When it was strongly heated, it was broken down into two products, that is calcium oxide and carbon dioxide gas, and this gas turned lime water milky, whereas in the first test tube after the reaction, calcium oxide was found to be lagging behind. So what you can see over here, one reactant broken down into two products, and that is decomposition reaction, the chemical reaction in which you can say for decomposition, two or more products are formed from a single reactant, that is decomposition reaction. If you take my first example, chivda if you take, and from the mixture you are separating rice flakes differently, groundnuts differently, sugar differently, that is decomposition reaction. From the entire chivda you are breaking it into small pieces, or you are breaking down the entire reactant into different products, that is decomposition. So see, each and every reaction, its name tells you something. Combination, first one, combining. Decomposition, breaking down, means name of the reaction itself tells you what the type is involved over here. One more example you can see over here, hydrogen peroxide or H2O2 naturally undergoes slow decomposition forming water and oxygen gas. So H2O2 decomposes. Here H2O2 is a single reactant getting broken down into water and oxygen. So the chemical reaction in which two or more products are formed from a single reactant is called decomposition reaction. I hope both the reactions have been understood by you very well. Now for decomposition, there are two types. The first one is thermal decomposition. You don't have to go into details much. Thermal means here you can see strongly heated. Heating, thermal means heat energy has to be provided to carry out this reaction of decomposition. So it is called as thermal decomposition, whereas the next type is electrolytic decomposition. We take up an example, then you will understand. Water decomposes into hydrogen and oxygen gases on passing electric current through acidulated water. That is water H2O. It will break down into hydrogen and oxygen when electric current is passed through acidulated water. So this breaking down or this decomposition takes place by means of electrical energy, and it is called as electrolysis. You have studied about electrolysis in chapter number 5 in the 9th standard, acids, bases and salts. So such a type of decomposition is called as electrolytic decomposition. This is the reaction, water getting decomposed into hydrogen and oxygen gases. So here two reactions we have completed. The first one, combination. The second one, decomposition, and the two types of decomposition reactions we have studied. Third one you will love very much, displacement reaction. Displacement, to understand the concept, I will take up a very good example of the classroom. There are good students in the class who are very attentive and focused, whereas there are some students who are notorious and they are attention seekers. They want to seek the attention of other students by creating some or the other nuisance in the class. So A, B, C. Suppose we take A, B, C, D. 4 students are there. A and B are sitting on the first bench. C and D are sitting on the last bench. Teacher has given them places. C and D are good students. They are concentrating on their studies. They are not mischievous. So they are given the last bench because teacher trusts them. Whereas A is very notorious. B slightly notorious. So they are made to sit in front of the teacher on the first bench. As soon as the teacher leaves, what will A do? It will get up from its place. It will go to the last bench, and then by getting angry or creating some scene over there, it will pick up the C from its place, it will tell C, go and sit on the first bench over there. Now class teacher has left and A will sit on the last bench to make mischief. This is nothing but displacement reaction. The reaction in which the place of the ion of a less reactive element in a compound is taken by another more reactive element by formation of its own ions is called displacement reaction. The original positions are displaced. The notorious child has taken the place of a less reactive child. Why? Because that child who is sitting on the last bench is a good child which does not like fighting or does not like talking with that child A. So what that child C will do, it will quietly get up from its place and it will go and sit on the first bench, and that place will be taken by that highly reactive child which is A. So same reaction occurs over here. You can see with the help of an example, copper sulfate which reacts with iron. So here iron will displace copper from its position and it will sit in the position of copper. So FeSO4 will be formed with the liberation of copper. Such an example is called displacement reaction. I hope all of you have understood. And the last one is double displacement. Now here don't infer कि teacher displacement only one child gets and displaces. Here double means A and B both will get up and C and D will be displaced. No, here a very simple concept is the reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reactions. Means a reaction in which a precipitate, you all know what is precipitate. It is always in the solid form. So when a precipitate is seen in any of the reaction, such a reaction you called as double displacement reaction. We take up a very good example here. In one beaker you take a solution of barium sulfate, that is BaSO4, and then to that beaker you add potassium chromate, that is K2CrO4. In the first beaker barium sulfate was taken and potassium chromate was added to that beaker and then it was stirred. What was the reaction over here? Barium sulfate, it reacted with potassium chromate forming a precipitate of barium chromate. This is the precipitate and the formation of potassium sulfate. So in this reaction you can see the presence of a precipitate, the formation of a precipitate by the exchange of ions. Here this chromate ion is exchanged with sulfate and such a type of reaction is double displacement reaction. Now for this reaction let us see the different questions which are asked. What was the color of the precipitate formed? Here now we are not able to show you the reaction. So when this reaction is carried out, the color of the precipitate which is formed is yellow. Write the name of the precipitate, barium chromate. Write down the balanced equation for this reaction. This is the balanced equation. Will you call this reaction a displacement reaction or a double displacement reaction? As there is the formation of precipitate, it is a double displacement reaction. Such a type of question is very likely to be asked in the board exams. Prepare this answer thoroughly on page number 38. You can see in the textbook on page number 38 under the heading double displacement reaction, they have given this activity and they have not removed this activity in the reduction. So prepare it properly. What will be the question which will be asked? Add potassium chromate into the solution of barium sulfate. Stir the solution and answer the following questions. First will be what was the color of the precipitate, write the name of the precipitate, then write down the balanced equation and then whether you call this as a displacement or double displacement. So this 1 and 2 they can combine and they can prepare one question. This can be number 2 and number 3 they can ask under 3 marks. So here we end with all the 4 types of reactions. The first one was combination, in which 2 or more reactants are combining to form a single product. Second was decomposition. Here the chemical reaction in which 2 or more products are formed from a single reactant. Displacement, the reaction in which the place of the ion of a less reactive element is taken up by a more reactive element. And double displacement, the reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reactions. After this, the two different types of small reactions we are going to study, that is endothermic and exothermic reaction. Here it is something simple. While writing the steps which are required for balancing an equation, I had told you in some cases heat has to be supplied from outside. Just now you had seen the example of calcium carbonate decomposition, which required the absorption of heat. So a chemical reaction in which heat is absorbed, heat is taken up, that reaction is called as endothermic reaction, and a chemical reaction in which heat energy is given out or liberated is called exothermic reaction. So here you can see in the first case, calcium carbonate only example we had seen. Calcium carbonate on strongly heating means heat is absorbed, decomposes into calcium oxide and carbon dioxide gas, an example of endothermic reaction. Here calcium oxide combines with water, liberating calcium hydroxide plus heat. This example, if you have not forgotten, just now we have studied under combination. So here heat you can see on the product side, then exothermic reaction. Now how to identify the difference? If they give you a reaction and they tell you to identify the type of reaction. Now here this reaction can be an example of endothermic, it can be an example of decomposition. Both are correct, so both logically they have to give you marks. But suppose they ask you specifically identify whether it is an endothermic or exothermic. How you will identify? If you see the heat on the left hand side or on the top of the arrow, then close your eyes and write endothermic. If you see the heat on the right hand side or the product side, then close your eyes and write exothermic reaction. I hope you have followed the different types of reactions, and I have also told you the type of questions which can be asked over here. One is direct, that is define any name of the reaction they will give, displacement, double displacement, and give one example. Or they will give you half of the reaction completed, other half you have to complete and then identify which it is. Or the third type is full reaction will be given to you. You have to identify the type of reaction and then define it. Okay, so you have to be prepared in all the ways and leave the rest to the board and be very you can say relaxed. This year also the pandemic is still going on, so paper will be very easy. Even though we have 10 chapters ahead of us, we will go very slowly, smoothly, and all of you are going to rock out the board exam with full marks. So keep in mind that yes, whatever may be the syllabus, kitne bhi chapters ho, we are going to pass out, rock out in a very good manner with flying colors. That's all from my side for today. Tomorrow we are going to proceed to the next topic of this chapter, that is the different factors which affect the rate of a chemical reaction. Then we will study oxidation and reduction reaction and redox reaction. So I request all of you, before you attend our tomorrow's session, kindly go through the topics and then refer the video. Thank you, dear children.